Hi, this video is about the inverse square law in science. To help make sense of this law, let's start with an analogy. Let's say that you've got a big bottle of butter spray, and this particular butter spray bottle always sprays out exactly 1 ounce of butter per press of the nozzle. And let's also say for simplicity that the butter is spreading out evenly from this spray bottle from a point inside of the nozzle. So it's just going to spread out perfectly in a nice sphere of, butter. So if this was the case, then let's say that you took a piece of toast and placed it at a distance so that it was exactly the right spot, that it got exactly 1 coat of butter, 1 ounce of butter on it. Okay, so 1 spray covers 1 piece of bread here, and that piece of bread receives exactly 1 ounce of butter, spread out evenly on the piece of bread. But what if you wanted to cover more bread in the same amount of spray, in the same amount of time? Well, if you took this piece of bread and moved it back to a distance that was twice as far away, then something interesting happens. Instead of covering 2 slices, the butter spray covers 4 slices. And that's because the butter is spreading out in all directions. And as a result, it's covering more area. So it's got to go a length and a width. So 1 spray now covers 4 pieces of bread. And now each slice, if you think about the math here, it's still 1 ounce of butter that's coming out of the spray bottle. But that 1 ounce of butter is getting distributed to all 4 slices of bread. And so each slice is going to get a little bit less butter now. Each slice gets 1/4 of an ounce. So it does cover more area, but the butter gets thinner as a result. What if we went 1 more unit away? We're now 3 times the distance away from that butter spray nozzle. So if you go 3 times the distance away, then now the butter is covering an even larger square. It covers 9 slices of bread. So in this case, each bread slice gets 1/9 of an ounce of butter. The butter is getting really thin at this point. It's having to cover a lot of area in 1 single spray. And so each slice is getting much, much less butter than it did when it was just 1 unit of distance away from the spray nozzle. So because the butter is expanding in all directions, as you get further and further away, it has to cover a much greater amount of area. We could go another unit of distance further than this, and it's going to have to cover 16 slices of bread instead of just 9. And that's because we're following a square pattern here. A distance of just 1D would be 1 piece of toast. A distance of 2D would be 2 pieces of toast, but a square, making 4 total slices. And then a distance of 3D would be 1, 2, 3 by 1, 2, 3 square, which makes 9. And so as you get further and further from the source here, the amount or the intensity of the butter follows something called an inverse square law. And the inverse square law is the intensity of a quantity, in this case butter, diminishes by the square of the distance from the source. So that's an important word here, square. We see the square here, and it's a mathematical term as well. When you square something, you're multiplying, length times width, for example. So you may be wondering why I would spend all that time talking about a butter spray. And the reason is because it demonstrates really well what the inverse square law is. And we see the inverse square law in a few different areas in nature. One of the most common ways we see the inverse square law is in the force of gravity. So I've tried to draw a picture of the Earth here, and I've drawn the center of the Earth to be this point. And we're going to, for simplicity, say that the force of gravity from Earth originates from this single point. Now, Earth is not a perfect sphere. There's different elevations that affect gravity, and so we're going to simplify things a little bit here, but it works for the purpose of what we're trying to understand about gravity. If you are standing on this little square patch of the Earth right here, you are 1 radius away from the center of the Earth. Okay. At that location, gravity is acting normal to you. And let's say for our example, you weigh 180 pounds. Now, if you were to double your distance from the center of the Earth, in other words, you move 2 radii away from the center, then notice what happens here. Gravity has to cover 4 times as much area. You've doubled the distance, but gravity is having to cover more, an expanding sphere of influence. And so because of that, there's 4 times as much area for the gravity to cover. That's 1/4 the gravitational force. So 180 pounds times 1/4 gives you 45 pounds. So you weigh 45 pounds at this location. If you tripled your distance from Earth's center, you're at 3 radii away from the center, then the gravity has to cover 9 times as much area. And so because of that, the gravitational force is 1/9 as strong, and you would weigh 20 pounds. I did that by doing 180 pounds times 1/9 to get 20 pounds. So gravity is one example of the inverse square law. We also see it in electrostatic forces. So think like rub a balloon against your hair, the electric force you feel from that, it diminishes by the inverse square law. The intensity of a light bulb, if it's radiating in all directions, it diminishes by the inverse square law as well. So we see this in a few different areas in nature. So let me end this video by showing you a little trick that I've learned in solving problems involving the inverse square law. And it's pretty simple and straightforward. If you have the distance changing by a certain factor, you often want to find how the intensity changes as a result. So let's start with an example here, example 1. Let's say the distance goes up by a factor of 5. How does the intensity change? To find the answer, you simply just do exactly what the law is called. You do the inverse square of 5. And what I mean by that is 5 becomes inverted. So instead of 5, it's going to be 1/5. That's the inverse of 5. And then you take the square. So you take 1/5 and you square it. Now remember the laws of exponents, the square gets distributed to the numerator and the denominator here. So that's going to be 1 squared over 5 squared, which would be 1/25. So if you go 5 times further from your source, the intensity is going to drop by a factor of 1/25. Okay, and that's the inverse square law. Let's do another one just to make sure it makes sense here. So let's say your distance actually goes down, you get closer. So you have half the distance to the source. Do the inverse square of 1/2. So you're going to take the fraction and invert it again. So it'll become 2/1. And it's called the inverse square. So we square it. So that becomes 2 squared over 1 squared, which would just be 4/1. And so you have the intensity goes up by a factor of 4. And then if you have some kind of odd number here, you do the same thing. You just do the inverse square. So if your distance changes by a factor of 3/4, let's do the inverse of that. That's going to be 4/3. And then square it. So 4 squared over 3 squared. 4 squared is 16, 3 squared is 9, and so we have your intensity changes by a factor of 16/9. So that's all I've got for you in this video. Remember, this day could be your last, so live on purpose.